All right, we're going to have a look at exercise 13.10. You can have a 13.10 from the IGCSE Year 11 textbook. Good text. And we're doing this lot here where it says, solve the following quadratics using either the quad formula or completing the square. And we're giving our answers to 2dp. I'm just going to work my way through a few of these. I'd like to do the whole lot. I think time won't allow me to do that right now. So let's start with number 1. And I'm going to use completing the square for the first lot. So completing the square, then I'll do a whole lot also using the quadratic equation. All right. So here we go. We've got an x squared minus an x minus a 13 is equal to 0. So my method of doing this, I'll restate the question first of all. X squared minus x minus 13 equals 0. I'm going to add 13 to both sides. I like restating it so I can see what I've done at each stage. So I've left now with an x squared minus an x. A nice big space here. I like the space there because I'm about to fill that with a rather important thing, and that is I take the b value. Now the b value is -1. You can't see the 1, but there is a 1 there. -1, so I'll put -1. I'm going to halve it, going to square it. I'm going to add that to both sides. Add it to both sides. I'm going to halve and square, and it's a -1. All right, there we are. So let's see how that plays out now. This is the bit. This is the really cool bit. So I'm going to put a square here, an x here, and I know that the contents of this bit here is just the bit in here, -1/2. Not the square, not the plus, not anything else, just -1/2. And I like it as a fraction. I could put 0.5, but I like it as a fraction. And what have we got here? We've got, we're adding now, we've got 13 plus now a half squared is going to be 1/4. -1/2 squared is 1/4. And I've got 13 plus 1/4. If I've turned that into a fraction, 4 13s, 4 3s are 12, 52, plus the 1 is 53/4. And I'm going to leave it as a fraction. I like it as a fraction. So I've got x minus 1/2 all squared is equal to 53/4. So I'm now going to rewrite that. And what I'm going to do is I'm leaving a bit of a space here now, 53/4. I'm going to find the square root of this side and the square root of this side. And this becomes plus or minus 53/4. And of course, the square and the square root cancel out. So now I'm left with x minus 1/2 is equal to plus or minus root 53/2. Because, of course, root 4 is 2. Now I'm going to add a half to both sides at this point. Add a half plus 1/2. So it's half plus or minus this thing here. But of course we can rewrite this. Of course, half disappears here. And I've got 1/2 plus or minus this. So really what I've got is 1 plus or minus root 53 all over 2. Because this is over 2 and it's a plus, and this is over 2. And of course, when we're adding or subtracting and we're keeping the denominators the same, I can just use a single vinculum and a single common denominator. All right, so now we can go ahead and solve. So this means that either x is equal to, and I'm going to do this in 2 lots here. So I've got root 53 on 2. Let's have a look. Square root 53. Okay, there it is. I'm going to, what am I doing here? I'm going to add 1 to that. So I'm going to go plus 1, divide it by 2, and there's my first answer, 4.14. Let's have a look at that. Yeah, that looks pretty good, 4.14. So 4.14 is my first answer. Or x is equal to, and I'll do the same thing. This time I'm going to go 1 minus 53 on 2. So here we go. So I've got, this is looking interesting. So I'm going to go 53 on 2, 1 minus, that's actually not 1 minus at all. We'll do it that way. 1 minus root 53 is -6.28. I'm now dividing that all by 2, and I got -3.14. So that looks good. -3, I put a negative there, 3.14. There is my second answer. And so I'm just going to express it as x is an element of -3.14 comma 4.14, and I'm expressing it like that because I want the smallest one first, followed by the second one. And hopefully that will make sense. Otherwise, do express it like this. This is probably the best way to do it. But if you want to use set builder notation and you're familiar with that, this would be another way of expressing the answer.